welcome to Seva Gurukulam, free online classes in science. How are you all? Nice? Good spirits? Okay. Just be attentive for half an hour. Okay? Come on, sit straight. Note down some of the important words. Now, our interesting study is about materials around us. In that, in particular, we are studying about metals and non-metals. So, what we have studied here, the last class, is about elements. Elements are the simple substances which cannot be broken into small parts easily. Okay, in that we have metals and non-metals. Around 80 plus are metals, the remaining are non-metals. And metals, what are the properties of metals? They are lustrous, means what? Shining. Can I give you an example of shining? Sun is shining, correct. What else? Diamond is shining, correct. So, the word shining is known to you very well. That is called lustrous. Non-metals have no luster except, come on, graphite. So, graphite has some luster. Where do you get graphite? Where you have seen it? Graphite you can find in the tip of the pencil. In a pencil there will be wooden cover, correct? Inside there will be a graphite. We call it as lead. But actually it is not lead. And also we have seen that metals are malleable. What do you mean malleable means what? When metals are heated, it can be beaten into sheets. That property is called malleability. So, metals can be beaten into sheets. Of course, only on heating, please note. A very important property. That is called malleability. But ductility is a point or is a drawn into wires. So, when metals heated, that can be drawn into wires. That property is called as ductility. For example, copper wire, silver wire, gold wire, and so on. Whereas non-metals are neither malleable nor ductile. Also, we have seen metals are good conductor of heat and electricity. What is the best conductor? Best conductor can be platinum. Next you have silver. Next you have copper. Next you have aluminum, etc., etc. Non-metals are poor conductors except, can you name the good conductor of electricity in non-metals? Yes? Yes, what is that? Example, graphite. Graphite is a good conductor of electricity. Even though it is a non-metal, it is a good conductor. How do you know it? Yesterday I told an experiment. Take a pencil, sharpen it on either sides, connect a wire. 2 pieces of wire to a bulb. The other 2 pieces to a cell. What do you observe? You observe that the bulb glows, which means that the lead in a pencil, or what you call it as graphite, is a good conductor of electricity. So, these are the things you already studied in the previous class. Shall we see the home assignment? How many have done it? All? Okay, let us see. First question, which of the following can be beaten into sheets? So, what is the criteria for that? It should be a metal. That means you must select which is a metal here. Whether oxygen is a metal? No. Whether sulfur is a metal? No. Whether phosphorus is a metal? No. Then which is a metal? Zinc is the correct answer. Answer is zinc. Then which of the following statement is correct? So there are 4 statements here. First one, all metals are ductile. Is it correct? No, all metals are not that. All non-metals are ductile. That is not correct. Then some non-metals are ductile. That is also not correct. So the correct answer is generally metals are ductile. So most of the metals are ductile. Means what? When it is heated, it can be drawn into wires. You have seen copper wires, correct? So that is a property called ductility. Now third one is very interesting question. It's a comparison. Some properties are listed in the following table. Distinguish between metals and non-metals on the basis of these properties. So for example, this was given, property was given, this you have to fill up. Coming to appearance, metals are lustrous, whereas non-metals are dull. If you take for example charcoal, it is very dull, black in color, correct? And metals are hard in nature. Can you name one metal which is liquid? Yes, come on. Yes, mercury. So all of them are hard except mercury. Non-metals also, almost all of them are soft in nature except diamond. That is what is said in Sanskrit. Vajradapi katorani mruduni kusumadapi. One should be as hard as diamond, but as soft as flower. Okay. So whenever you see some poor people or sick people or people in difficulty, you must be very soft with them. Whenever you see some rough and tough people, should be hard. Malleability can be beaten into sheets. Non-metals cannot be beaten into sheets. And ductility, metals can be drawn into wires. Non-metals cannot be bent. Heat conduction, metals are conductors of heat, whereas non-metals are insulators of heat. And metals conduct electricity and non-metals do not conduct electricity except, what is it except? Graphite rods. Graphite is a very good conductor of electricity. So that except word is very important in English. That is what you call it as but. Okay, this is the answer for the third question. Shall we pass on to today's topic? Today's topic is about chemical properties. So the first class we have studied about physical properties, appearance, all that. And today we are discussing about the reaction with the elements. For example, with the oxygen. What is the formula for oxygen? O2. It is a molecular state. Most of the metals and non-metals react with oxygen, forming respective oxides. So the compounds of metals are called oxides. It may be metallic oxide, it may be non-metallic oxides. Okay, for example, when magnesium ribbon is heated, it burns with a dazzling white color. Of course, some might have seen it. Just like a ribbon, it is called magnesium ribbon. If you heat it, It gives a dazzling white. Means what? Very difficult to see that color. What does it form? It forms magnesium oxide, MgO. And reaction is magnesium plus oxygen gives magnesium oxide. It's a white color powder. So magnesium is Mg, oxygen is O2, magnesium oxide is MgO. If you balance it, 2 Mg plus O2 gives 2 MgO. It is a metallic oxide. And what is the feature of the metallic oxide? It turns red litmus into blue, correct? And one more property, in case of iron, it has a very special property. When iron is exposed to more moist air, means in rainy season, moist means what? Contains more water vapor, more of water. A brown layer of rust is formed, and within 2-3 days, that is called ferric oxide. So some of you might have seen in your houses, ferric oxide is Fe2O3. So for example, this is iron, this water is added to that, and if you keep for some days, it contains some rust here. And what does that rust do? That turns red litmus into blue, because it is a metallic oxide, also called as basic oxide. So reaction is iron plus oxygen plus water vapor. That's why rusting takes place only in rainy season, but not in summer. You get ferric oxide. Formula is Fe2O3 2H2O. Why 2H2O? Nothing but water. Okay, so that is why you might have seen iron rods, iron doors, windows, etc. are painted. Why do you paint it? Just to avoid rusting, correct? And that is another property of metals reacting with the oxygen. Similarly, when copper is exposed to moist air for a long time, it acquires a dull green coating. You might have seen some of the vessels in our home. Some vessels, in the copper vessels, especially if you keep for a long time in rainy season, we get a green coating that is made up of copper carbonate and copper hydroxide. And the equation is copper is Cu, water is H2O, carbon dioxide is CO2, and moist air is O2. If you react this, it forms copper hydroxide, CuOH twice, and copper carbonate. There is nothing but green coating. And how to avoid it? You have to put a layer of metals inside. That's what you call it as kalai in Kannada. So by putting that layer inside, metallic layer, this type of green layer formation can be avoided. And suppose you have a green layer and cook it, use for cooking, that chemicals will go to our stomach, it gives trouble. So like this, like iron, like magnesium, like copper, other metals also react with oxygen. For example, sodium gives sodium oxide, potassium gives potassium oxide, copper gives copper oxide, like that. All the metals react with air, almost all, not all, almost all of the metals react with air or oxygen to form the respective oxides. And all these oxides are called basic oxides. What do you mean basic oxide? That means it has a property of a base. So when these basic oxides dissolve in water, they form what is called as alkalis. For example, sodium oxide dissolved in water form sodium hydroxide. And if you take calcium oxide, it becomes calcium hydroxide. These are called alkalis. And how do you test it? Testing is red litmus becomes blue litmus. And what about non-metals? Non-metals also react with air or oxygen, forming respective oxides. Carbon plus oxygen, carbon dioxide. Sulfur plus oxygen, sulfur dioxide. Like that. And they are called acidic oxides, because when they dissolve in water, they form respective acids. Carbon dioxide plus water becomes carbonic acid. Sulfur dioxide plus water becomes sulfurous acid, like that. Okay, so there are two types of oxides called basic oxides made up of metals. Another one is acidic oxide made up of non-metals. And acidic oxide on dissolved in water forms acids like sulfuric acid, nitric acid, hydrochloric acid, all these are. Whereas basic oxide dissolved in water form hydroxides. Okay, so about which you are going to study later in detail. These are only basic things. Metallic oxides are basic in nature, which can be tested by change of color of litmus paper, red to blue. You have seen red litmus paper? You have seen? Yes. So that is a change you have to observe here. And now coming to one more property. See, sodium metal is always kept or stored in kerosene, in potassium also, because it reacts with air forming sodium oxide. Also it reacts with cold water with a hissing noise vigorously. It reacts with the water vigorously. A small piece of sodium, if it is put to water, it revolves all around the surface of water. Have you seen it? It gives a hissing noise, and it produces what is called as hydrogen gas. So if you want a reaction, sodium plus cold water, H2O. H2O means what? Sodium. No, H2O means water. So sodium plus water gives a sodium hydroxide. Nothing but a basic oxide, or is a base plus water. So this is called the reaction of sodium. Similarly, potassium plus water gives potassium hydroxide plus water. And here this is a very important word, hissing noise, because the reaction is very, very fast. That is why you use the word vigorously. That's why sodium is always kept in kerosene. They don't keep in water. Why? Because it reacts vigorously with water. They don't keep it outside also. Why? Because it forms sodium oxide when it is exposed to oxygen. Okay. Home assignment. What happens when magnesium burns in air or oxygen? So if you want to burn all in its own accord, you must keep a spirit lamp or a Bunsen burner and keep that magnesium with a handle. So what do you expect? Iron is exposed to moist air, not dry air. Then you must answer the question, sodium is always kept in kerosene. Why? Give an example for basic oxide. How do you test it? Okay, now let us see what Bhagwan Baba says. Students are future redeemers of the nation. Therefore, they should take the path of spirituality. So Baba says, all students, boys and girls, they should be adopting the path of spirituality. Means practice namasparana, meditation, reading of good books, keeping in a good company and all that. Then only you can face the challenges of life. Okay, this is what our most beloved Bhagavan Sathya Sai Baba says. Come prepared with the answers. Thank you.